Alright, this video is going to take a look at how to take the derivative of a fraction by using the quotient rule. So if that's been giving you some trouble, here's one more example of how that works. To make this a little easier on ourselves, I think we're first going to rewrite this. The square root of x on top will be much easier to deal with if it's x to the 1/2. And then the denominator will stay the same, x to the third plus 1. So to start this off, we've got to do the quotient rule first. So f prime, our derivative, is going to equal the derivative of the top, so that will be 1/2 x to the negative 1/2 times the first, or times the bottom, x to the third plus 1, minus the derivative of the bottom, which is 3x squared, times the top, x to the 1/2, over, it's going to stay a fraction, take the bottom, x cubed plus 1, and square it. So if you want to take a look at what we just did there in rule form, we took the first term, f prime of x equals the first term, x to the 1/2, the top, and we took the derivative of it. Multiply that by the bottom, x to the third plus 1. And this time we subtract the derivative of the bottom, x to the third plus 1, so call that prime, times the top, which is x to the 1/2, all over the bottom squared, x to the third plus 1 squared. So that's the quotient rule. The hard part is now simplifying that to make it look nice. So we can do a few things here. Equals. One of the first is we can distribute here, and then over here we're going to be adding the powers. Okay, so take that away so I don't misread something. First, let's distribute. We'll have 1/2 x. We're going to take the negative 1/2 and the 3, add those together. That'll be 5/2. Plus, distribute to the 1, so that's 1/2 x to the negative 1/2, minus, now the second term we can take these powers again and add them, so 2 plus 1/2 is actually again 5/2, so negative 3x to the 5/2, all over the same denominator, x to the third plus 1 squared. We can simplify the top a bit if you actually take a look at the first term and the third term. Those have the exact same power, so they are like terms, so we can add those together, in this case subtract. Negative 3 and 1/2 gives you 5/2 x to the 5/2, that's a coincidence that those are the same, plus 1/2 x to the negative 1/2 over x to the third plus 1 squared. Now there's a couple more things we can do to simplify this. I'm going to do them one by one so it doesn't become too complicated. The first one is to multiply by 2 over 2. We have 5/2 and 1/2 as coefficients. It'd be nice to get rid of that, and multiplying by 2 will do that. But we also have to multiply by 2 on the denominator. So that will just get rid of the denominators up top of our fraction. So that will be 5x. Oops, I made one mistake I just saw. There should be a negative in front of that 5 right now, because it was a negative 3 plus 1/2, so that's a negative 5/2. But the 2 will still go away, the 2 will still go away, so it will be a negative 5x to the 5/2 plus x to the negative 1/2 over 2 x to the third plus 1 squared. And there's a little bit more we can do with this, and that will be obvious if I write this with square roots. So negative 5 square root of x to the 5th plus 1 over the square root of x over our denominator, which isn't going to change yet, plus 1 squared. As you can see, there's 2 square roots up here in the numerator. It'd be nice to get rid of those, and so what we're actually going to do is multiply by the square root of x. I'm going to squeeze it in over here, and on the top and on the bottom. And that will cancel out both square roots actually, and make this look a whole lot nicer. So this is going to cancel out right here, and this on the bottom is going to cancel out completely. So what we'll be left with is negative 5 x to the 5th plus 1 over our denominator, which is now going to have a square root, so it will be 2 square roots of x times x to the third plus 1 squared. And that is our derivative, f prime at x, which you might rewrite one more time as 1 minus 5x to the 5th over the same denominator. Square root of x times x to the third plus 1 squared. That problem is fairly difficult because of the amount of simplifying you have to do, but hopefully you can see the one step of the quotient rule right over here isn't super difficult, if a bit tedious. I hope that helps.